Thank you for coming back today at the Physics Mindset channel, the channel which is there for you to mentor you in the solar installations, electrical installations, and electronics. Okay, we have seen the inverters and we have seen that it is an electronic device which converts DC to AC. Now we want to see. I wanted us to go into the calculations, how to calculate your inverter. Okay, then I remember something that you don't need to miss the waveforms which the inverter produces. There are different waveforms with they like different electricity. Okay, for technicians you'll understand this, and the beginners still you'll understand this. I didn't want to jump this. I had to bring this to you, and we studied it. Then we see the specification which shows which type of inverter is good for you or for your client. The specification and meaning we shall talk about the technical information. Before you go to buy an inverter, what do you need to know in your mind, or what do you need to know technically? You need to know the specifications, which we are going to look at in the next video. And here today, we are going to talk about the waveforms. When an inverter, this is our inverter, it has outputs. Okay, these are outputs. Output, which is AC, because the input is DC, then output is AC. Now, on this output, we have waveforms. Some inverters bring AC, let us say a 220 AC, when it is not pure or when it is modified. And that's what we're going to look at here. We have types of waveforms, which is pure sine wave and modified sine wave. These waves will help us when you're buying an inverter. They write for you. I think each inverter which is of original, you will have that sticker which is written either a pure sine wave or a modified sine wave. And we are going to see which is a pure sine wave, which is a modified sine wave. Sine wave, I mean, on the output, this is our inverter. Okay, this is the output. Let us say the output is 220 volts AC. The input is 12 volts DC. Okay, now this 220 volts, it has either, the output is either pure sine wave or modified sine wave. Pure sine wave, I mean, the wave will be like this. Pure, that is AC wave. Okay, this is half wave, full wave. When you bring this wave here, it becomes a full wave. Okay, I say if you bring this wave, if it is here like this, this becomes a full wave, pure. Now there is either pure sine wave or modified sine wave. It depends. Now on your inverter, they write on it, if the wave, it will be 220. The inverter will produce 220 output, but is it pure sine wave or modified sine wave? We are going to see why we need to look at the pure sine wave before we go to the calculations of an inverter. I had to bring this into existence so that we know everything about the inverter. I don't want to leave anything. After here, we shall see the specification. Before you go to buy an inverter, what do you need to specify? What do you need to see in your mind? What is the load of my... We shall see the specifications which you need as a technician, as an electrician, or a solar installer. Even customers nowadays, they go and buy their own inverters at the market. So I'm going to show you what you need to know before you go and buy the inverter. After this, we shall see the specifications of an inverter. So now, let us today look at, this is the sine wave, and there is also either this inverter produces sine wave. If it doesn't produce sine wave, it will produce modified sine wave inverter, and it will be a type of modified sine wave inverter, either a pure sine wave inverter. Now this is a pure sine wave. A modified sine wave, it will be like this, like this, like this, like this, okay? And this is our timeline. It is modified. This. We're going to see a clear graph of these types. This is a pure, this is sine. So let us first talk about the pure sine wave. Okay, let's deep inside the pure sine wave. Then after we go to the modified sine wave. Okay, let me remove this. Now a pure sine wave. Pure sine wave. Listen the name. Pure sine wave. Pure sine wave. We are talking about the inverters. The output of an inverter. It either a pure or modified. But if it is pure, I told you this is technical. Listen the words you're using. Technical terms, they show what the word is meaning. Pure. Like how we saw the types of inverters. We talked about on-grid inverter, which is on-grid. It is on the utility, okay? Off-grid inverters, which is they are off-grid. Then we say hybrid. Hybrid, we say types of, there is off-grid inverter, on-grid inverter, and hybrid inverters. Hybrid means you combine off-grid inverters and on-grid inverter, you put them together to make a hybrid inverter. Now, check the name. And these inverters have outputs. Now we are looking at their output. Are the outputs good for us, for our machines, the TVs, everything? Or there is something we need to know about the output of an inverter. Now we are going to talk about the output of an inverter. Then we shall go and see the calculations. After here, we shall see the specifications. After I show you how to know the specifications, which when you're going to buy your inverter or when you're designing an inverter, the things you need to look. After seeing this, then you can go and buy your inverter. Okay? Now let us talk about the pure sine wave. We shall talk about the pure sine wave. We talk about the good part of it, the function, the disadvantages and disadvantages of a pure sine wave. We see if an inverter is written on, an inverter, when an inverter is written on a pure sine wave, always read on any word on an inverter. You know, it is an electronic device. So meaning they are going to technical, the electronics. They are going to design something inside that inverter, which will convert DC to AC. Now for you need to be very keen so that you read everything they want. They write on it. Okay? The manufacturers will give you the information what he has done inside the inverter. Either the transformer winding, either the transformer is going to produce 110 volts or 220 volts or 240 volts. Always read that as a technician. Okay? Technically. Don't just buy an inverter because it is painted good. No. Make sure you read the information on it. We need the information. We don't need the color of the inverter. It may be gold. It may be silver. But the information written on an inverter, always read everything on the inverter. Before you buy, get the inverter. Read on it. Every word written there. The manufacturers is giving you a technical information about what is designed inside the inverter. Now there is the input, there is the wattage, there is the output. Okay, is the output pure sine wave or the output is modified sine wave? Okay, it will depend on what you want. Let us see the differences between the pure sine wave and the modified sine wave. Both the output will be the same, 110 volts, either 220 volts, either 230 volts, either 240 volts. But are this output pure sine wave or modified sine wave? I didn't want to leave this information behind before we go to the calculations. And it is so important for us to know, because every info you'll see inverters, you'll always have that thing to read on them, and you'll see what you need. Either they write for you, a manufacturer write for you pure sine wave, or he will write for you a modified sine wave. Then you will know technically that There's something we learned about the pure sine wave. What are the pure sine waves? What are the modified sine waves? Then you will have that either when we're going to tell your customer that I'm going to buy for you an inverter which is a pure sine wave. They are also an inverter, the same wattage, the same voltages, but not pure sine wave when it is a modified sine wave. Okay? Talk about that technical information, give it to the customer, and it will help you as a technician. And the customer will believe in you that you know what you're going to buy for him or her. Okay? Let us talk about the pure sine wave. Pure sine wave inverters. Pure sine wave inverters. Pure sine wave inverters. Listen to the name. Pure sine wave inverters. The wave is like this. You know, electrical wave, AC. Let me say an AC wave. AC wave is, we have a line like this. After having a line like this, we have a wave which shows an AC wave. We have a wave which shows a DC voltage, and we have a wave which shows an AC voltage. But in an AC voltage, DC voltages is one type of wave. But in an AC voltage, we have different types of waves. Okay? Today we are looking at the output of an inverter. We are looking at the pure sine wave. Our inverter will produce 220, but we don't know if it is pure or modified. Now I want to see which wave is good for us. AC, always AC wave, AC voltages have this wave. We have a half, then we have another half. Then we have another half. Then we have, it goes like this. This is a wave for AC voltage. And here, from here, this from here, that is the time taken. This is the distance of a wave showing pure. And if you bring this to here, let us show that this wave has come to here. You see, it is moving on. Well, this is half. You know, electricity, it is either a live or a neutral. Power goes like this and power comes back. Power goes in live and power comes back through the neutral point, which is called the return. Okay? Without a neutral point, we can't have this wave. We need to have a neutral point. Then for the return, that's why we have space. And this space, it shows if this wave comes, the return will be here. Okay? And this is the pure sine wave. Whenever you're going to buy an inverter, always read that there is a pure sine wave. Is it a pure sine wave or a modified sine wave? It will show you. That information will be there on an inverter. Be a true technician. Be a technician who is going to give your customer the proper thing you need your customer to have. Always explain this to the customers. Okay? To the customer who don't know, who never went there, but you have got a chance and you have heard this video and you are learning something, why don't you tell the customer that the inverter I'm going to buy for you is going to be of a pure sine wave, and it is going to be a hybrid type of inverter, or off-grid type of inverter, or on-grid type of inverter, but it is in a pure sine wave or modified sine wave. Now this is a type, a pure sine wave. Pure sine wave. It is an AC sine wave. Wherever you see this signal, just know that is an AC. There is an AC present and it is very pure. It is, if it is 110 volts, pure. It has no signals. It is pure. Let us see let us see the definition of pure sine wave. They are telling us that a pure sine wave, it is an inverter. It is an inverter which produces. It is an inverter, either off-grid inverter, on-grid inverter, or hybrid inverter. It depends which type of inverter you have. But this is an inverter which produces smooth electricity. This is an inverter which produces smooth electricity. Smooth electricity. The smooth electricity which the inverter produces, it is similar to the utility power. It is similar to the utility power, meaning, utility power, I mean the company which is responsible for supplying you, whatever country you are. Every country has that company which supplies electricity to each household, okay? And that company is owned by the government, which is called the utility power, the utility company or power, the utility company which supplies power, okay? Now let us say this is an inverter which produces smooth electricity similar to the utility power. Our electricity at home, that electricity doesn't disturb us. It is quiet. It is constant. If it is 110, it is 110. If it is 220 volts AC, it is 224 AC. If it is 240 volts, 240 volts. And it is having this waveform, a pure sine wave. That is similar. Those inverters are very, very good, which produces exact power, which the utility power or utility companies of any country. That power, that inverter which produces this kind of electricity is very, very good for your customer. I recommend a pure sine wave. Even though we are going to see the modified sine waves, but I recommend the pure sine wave. Always buy for your customers pure sine wave. When you see a word pure sine wave, don't complain. Just buy that for your customer. Now, let us see what good if we are going to see the advantages and disadvantages of this pure sine wave. Now we have seen that this pure sine wave is very good for very good for our refrigerators, okay? It's very good for our TVs, and it's very good for the computers. It's very good for medical equipment. Medical equipment, like in a hospital, they don't want electricity which is not stable. We want which is pure. If it's 110 volts, it is 110 volts. If it is 240 volts, it is 240 volts. Pure sine wave of pure electricity. This is the wave of pure sine wave. Now, on air conditioners, they also need pure sensitive electronics. Some electronics don't want unstable electricity. They want pure sine wave electricity with this kind of wave. Electricity which is flat. If it is 110, it is 110. You will not find it to be 109 volts. It becomes, once you switch on 110, you receive your 110. Here come the sensitive electronic parts, sensitive electronic gadgets. And once you switch on and this gadget gets from it's supposed to get 110. Then this power, when you switch on the inverter will send you 112. You see, some 2 volts which has increased, it may affect our sensitive electronics. And that electronics, that's why you see the technicians, you will receive now that work for repair. They repair when the bulb or when the electronic gadget has blown because of a small increase in the voltage, and has blown the circuit inside our electronic, and those are the circuits we call sensitive electronics. This sentence is like in the medical equipment. In the medical, in the hospitals, the heart, when they're working on the heart, they need a pure sine wave inverter. Because when the grid or the utility company power, okay, the government power goes, we need to have a standby pure sine wave inverter in hospitals. I'm talking about the point of medical equipment. You can't use any type of inverter rather than a pure sine wave. The inverter may be hybrid. The inverter may be off grid. But once the power goes, the inverter may be on grid or off grid or hybrid. Make it sure that our inverter is of pure sine wave. And I was explaining about the heart. Now, in the hospital, they're working on the heart. And the heart needs a proper pure voltages to keep it pumping. You know, we are electrified ourselves. We have electricity inside us. Now, sometimes I think you have ever seen someone who has been shocked by electricity. Still, electricity is the one which is used to bring that heart to life. When you are shocked by electricity first shocks the heart and stops the heart. And in the hospital we have that these are electrified machines which shock the heart to pump again. You see? But that electricity to which is used, it must be pure. Okay? And this is how a lot of points, a lot of gadgets which are used on our pure sine wave inverters. Let us see the advantages of these pure sine wave inverters and the disadvantages of these pure sine wave inverters. Then we can see what about the modified inverter. What is a modified inverter? The output of an inverter is it either modified or pure, which is good. We say in pure, the inverter will produce a smooth electricity which is similar to the utility power. That is pure, meaning an inverter will produce exact power which is the same as the government power which is giving us in our households. I think that is a very, very good inverter. Let us see its advantage and advantages of pure sine wave. The advantages of pure sine wave and the disadvantage of a sine wave inverter. We say the sine wave, as I told you. Now let us look at the advantages of a pure sine wave. One, we have it is safe for all appliances. It is safe for all our appliances. Okay? This pure sine wave, because the wave, as I showed you, the wave, we say we have the timeline, we have like this, then our waveform, which is pure. Okay, this is the waveform which is pure sine wave, meaning it is safe for all our appliances. The neutral goes, the output, the live comes, the neutral brings power, the live brings power, the neutral returns the power. It goes, come back, alternates, and it comes back. But in a DC only, DC current, which is direct current, it only goes direct. It doesn't come back. If the bulb is using that voltage from the battery, it doesn't come back. But for an AC, this is an AC, because a DC current, let me write here, when it is a DC current, when it is a DC current, its waveform will be like this, meaning it doesn't come back, it goes direct. Now an AC is it goes and it comes back. Number one point, we said it is safe for our appliances. All our appliances are safe when you're using a pure sine wave. That is one of the advantages of a pure sine wave. The appliances for all are safe when you're using a pure sine wave inverter, an inverter which is producing electricity which is in the form of a pure sine wave. It is, number two is, it has a better efficiency. It has a better efficiency. What does it mean? You said a better efficient, this point, better efficient, the higher the efficiency, the lower the current loss or the voltage loss. Okay, they mean when the efficiency is high, when the inverter, when our inverter is producing this wave, is producing an output. If the output is 10 volts, 110 volts, there is no excess power which is lost. Okay, when the efficiency is high. That's why we monitor, always read the efficiency of the inverter. That is a sensible part when you read the efficiency of the inverter. When the inverter has high efficiency, it means it occupies all voltages, and all voltages is given to you. There is no voltage losses, okay, in high efficiency. But when the efficiency is low, there will be losses of efficiency. The inverter will send some voltage to your gadgets, the TVs, the refrigerators, but some gadgets, some voltages or power will be lost. Let us say, mostly in this case, this is another point. Less noise and heat. I was going to explain the efficiency in terms of heat. Some inverters heat up. Once they heat up, heating is the loss of power. It also loss of power. Instead of this power being used by your bulb, it's being used by producing heat. That's why you feel an inverter when it is a bit heat. Like when a transformer is heating. Transformer is heating because it is transforming or stepping up the voltages. It produces some heat. That is, the efficiency will go low because we are losing power. Losing power, I mean, we are getting our power from the battery. And the power from the battery will drain very fast because of that heat. That consumption of power from the battery, we are converting it into heat energy instead of converting it into electrical energy. Okay, now the efficiency goes down. But for pure sine wave inverter, which are producing pure sine wave power, the output with this waveform, the pure sine wave form, there will be no noise, less noise. Okay, you will not feel any noise. The inverter will be at calm. The inverter will not make any noise. Either the transformer is stepping up the voltage, you will not hear that. Some inverter make some hum, some noise from them. Okay, when they are converting. Oh, when some inverters, when you plug in and you put on your loads, either a fridge, a TV, your lights, you'll hear that noise when the inverter is operating. Okay, the inverter will make a bit of noise. But these pure sine wave inverters, they will not make any noise. Okay, and no heat, less noise and heat. There will be no heat. There will be small heat, as you know, when electricity is functioning, when the components or appliances, when the appliances are driving power from the inverter, and when inverter is converting power from DC to AC, there will be some energy which is needed. And when the transformer also is stepping up the voltages from 12 volts to 110 volts or 140 volts, there will be another energy which will be needed, and this results bringing a bit of small heat, small heat like this. But some other inverters which are not pure sine wave, which are not producing this waveform, they will have a lot of heat around it, meaning leading to loss of power or loss of energy or current loss in our system. Okay, now disadvantages: save for our appliances, better efficiency, and less noise and heat. You'll find that pure sine wave are better to use because there is no heat, there is no noise, and it is good for our appliances. We are sure that if my phone uses 5 volts, I'll have 5 volts. If my charger wants 220, my charger my inverter will produce 220 volts for my charger to charge my phone, and my phone will not blow. That is the use of a pure sine wave inverter. Now, it has one disadvantage. One disadvantage like this. Which disadvantage is, even though it has all this good efficiency, less noise and heat, and it is better for all our appliances because they are safe. There are no surges of electricals. The disadvantage we are seeing is it is more expensive. It is more expensive. Nothing to do, but it has everything we need, but it is expensive. That is the only part of a pure sine wave inverter. Once you read an inverter that is having a pure sine wave, please just buy it. Even though it is expensive, you are making some savings, because once you buy an inverter which is not pure, okay, pure, which is not having a pure sine wave, this is a sine wave of pure or electrical or AC sine wave, though it is expensive, please save some money and go and buy that one. I recommend to buy a pure sine wave inverters. Always read on an inverter, either it is modified inverters or pure sine wave inverter. Okay? Technicians, electricians, or engineers, please note this. Even customers, some customers who go and buy for them themselves, they think technician is going to steal your money or to remain with some balance of your money. Please buy sine wave inverter. Have the knowledge about inverters, but I'm giving you everything about inverters. I'm not going to leave anything for you. Everything I will deliver to you, and you decide what to do. If you don't take notes about the things, you will end up buying inverters today, tomorrow. You buy inverters, done buying one thing. And if you don't buy a sine wave, you'll end up your gadgets being blowing all the time. The moment you switch on an inverter, power will be a spark, high voltage. You remember when you switch on something which is bringing on electricity, the fast electricity, before the electricity gets stable, your components may blow. That's why I recommend a pure sine wave. Once you switch on, it gives you the exact voltages you want. Okay, now let us go and talk about the modified sine wave inverters. What are the modified sine wave inverters? Yes, we have talked about the pure sine wave, but let us talk about the modified sine wave inverters. Now, let us talk about, since we have seen the pure sine wave inverters, now let us talk about the modified sine wave inverters. As we say, these are the outputs of an inverter, either on-grid type, off-grid type, and hybrid type. These are types of inverters, either hybrid, but the output is the output modified or pure. Since we have seen about the pure sine wave, let us talk about a modified inverter. Now, a modified type of inverter, or a modified sine wave type of inverter, which produces a waveform in a modified sine wave. Let me give you the wave. We have our timeline. Okay. Now let's make a wave for a modified sine wave inverter. It comes like this, 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 like this. It continues like that. Okay. It continues like this. Now, this is a modified sine wave inverter. Its wave is like this. Always when you're going to buy your inverters, read or see the sine wave or ask, which wave is this? This inverter produces which type of wave? Is it a sine wave, a modified sine wave, or a pure sine wave? Sine wave means is an AC, sinusoidal. Okay? Is this inverter is a pure sinusoidal wave, or is this inverter produces a modified sinusoidal wave inverter. Okay, now this is the bars of a modified sine wave. Now this type of modification is not really pure. If we get this bar comes here, it's not really pure and a return, meaning it can push high voltages at the beginning, then it stabilizes after. This kind of modification, the voltages are modified. If it is, this is AC, this is AC graph, but modified. Let us say if it is 110 volts, 110 volts AC, the inverter is converting DC to AC and producing 110 volts, or 240 volts AC output of an inverter. Now this output, before we go here, let us see the definition of these modified inverters. Modified sine wave inverters. Modified sine wave inverters. They are saying these inverters produce a rough AC output. These inverters, they produce a rough AC output. Its output, the output of an inverter, this is the output wave of an inverter. It will be an AC from a DC, from a 12 volt DC to AC, either 110 volts AC or 100 or 240 volts AC. But this is the output of this kind of inverter, a modified sine wave inverter. They have said it produces, it is rough. You see its graph? It is rough, it is not clear. Okay? Meaning your gadgets may even be in danger the moment you use this type of inverters. Okay, we are going to see its advantages and disadvantages. I think it has a lot of disadvantages because the definition of a modified sine wave inverter, it produces a rough AC, an AC which is not stable, it is rough. If it is 110, you might even get 115 volts, meaning your TV may be blown. Okay, either your refrigeration, your air conditioners, it may be either a hybrid type of inverter or off-grid type of inverter or hybrid or on-grid type of inverter. But once it produces this kind of modified sine wave to your gadgets, be sure it may either, instead of bringing 240, it can even heighten the voltage to go to 250 volts, and your gadgets will be in trouble sometime. Though I'm not talking bad to the modified type of inverters, but you be not safe, okay, than using a pure sine wave inverters. Okay, now let us see the advantages and disadvantages of these modified sine wave inverters. Are they good for us? Do they have some advantage good for us, for our appliances, or do they have disadvantage for our appliances? You know, we are looking for an inverter which converts DC from the battery to the AC, and we have the inverter. Now, does this inverter produce which waveform? Are the waveforms or electricity? Some people don't know this. Once the inverter produces an AC out, it is done, it is okay. But it is not okay. The okay part will come when you realize that either it is a pure sine wave or a modified sine wave which is coming out to power your gadgets in the house. Okay, even when you're designing your solar system or your calculation of inverter, please, I want a quality work, quality technicians, pure quality. Have the pure knowledge as a technician when you're dealing with solar systems. Don't give a customer fake things. Tell him if this is this amount and a pure sine wave inverter, the same voltages. Okay, an inverter may be pure sine wave and another inverter may be modified sine wave. Okay, their output, those are output waves but they are all producing 240 volts. Don't say that because it is producing 240 volts, just buy because it is cheap. You buy a modified sine wave. We shall see if it is cheap. I don't know. We shall see on the disadvantages, and disadvantages will tell us. Then you go for a pure sine wave or modified. Both are producing 240 volts, but the output waves, which is better for you? A pure, as we have seen, a pure is clean, is smooth electricity, but a modified is rough. It has a rough electricity. Now, do you prefer to use a pure, which is smooth electricity, which will not damage your appliances, or you use the rough one? It depends. Sometimes it depends even on the cost. Some customer may be not having the money to buy a pure sine wave inverter. That's why I need technicians which are true when they are installing the solar systems. Tell the client that this is the inverter, the same type, but the different waveform output. They give you 240 volts, both of them, they give you 240 volts, but the output is not the same. The waveform, okay? The voltages is the same, but the waveform, either pure or modified. Let us see the advantages of modified and the disadvantages of modified. We compare which is best. Is it pure and modified? Let us see. Check which is better, the pure sine wave or a modified sine wave. Okay. Now, let us see the advantages of modified sine wave. We saw the advantages of pure sine wave. Okay. Now let us see the advantages and the disadvantage. The advantage of this modified sine wave: one, it is cheap. The modified sine wave, it is cheap because of it brings its electricity. Its electricity is rough. The output electricity, let me say, the output electricity from the inverter is rough. Check that. For a pure sine wave inverter, which produces pure sine wave, an inverter which produces modified sine wave, for a pure sine wave, the electricity is smooth and it is similar to the utility companies which give us power in the house. While in a modified sine wave, the electricity which is produced by the inverter is rough, is not stable. Okay? That's why we have this man here. It is cheap and everyone will run on it. Everyone will come on this because it has an advantage that a modified sine wave inverter which produces a sine wave which is modified, it is cheap. While for pure sine wave is expensive to buy it. It is more expensive, but you save much than buying a cheaper inverter which will spoil your appliances. You see, the inverter will work, but you will buy more TVs, more fridges because of unstable power. The power is rough. It has a simple design. You find it is very simple, very simple design, small in size. Okay, it has no complication inside it because of that simplicity, and is cheap. And technician will run. But once you watch this video and you master the thing that to buy an inverter, you need to buy a pure sine wave. Though it is expensive, but please explain to the customer that he adds on some money and you buy a pure sine wave. Let us see the disadvantage of a modified sine wave. A modified sine wave, when its output electricity is rough. What are the disadvantages? We have the output roughness of electricity from an inverter. The output of an inverter will damage. It will damage the sensitive appliances. It will damage your appliances, your TVs, your refrigerators, your lights, all sensitive appliances. This inverter, either off-grid or on-grid or hybrid inverters, those are type of inverters. Once you read that it is modified inverter, yes, it's going to be cheap, it is going to be simple, okay, but it will damage the sensitive appliances, okay, appliances which are mainly, let us say for example, appliances which are mainly using 220 volts AC. Now you switch on your inverter, it can go to 240 volts, then it comes back on 220 volts to stabilizes that small interval, that spike, okay. Now your gadget or either your TV will blow in that small second. The spike will go high of the voltages, will go high until blow the TV. The moment this inverter, the modified wave inverter which produces the modified wave, the modified sine wave inverter, the moment it stabilizes its voltages, it has blown your electronics or your sensitive appliances. The next disadvantage of these modified inverters are they produce noise. They produce noise. The moment you switch them on, you give them the load, you'll feel the fan, the noise from the fan. Okay, just know that is modified sine wave inverter. Their waves, the fan wave will give you noise. Then the pure sine wave forms of the pure sine wave inverters, it will be less noise. You will not hear the noise. Okay, even the heat will not be there. But this, you will hear the noise from the inverter when it is operating. Just know that this is a modified sine wave inverter. Okay, in their fan they will make noise. Even the transformer, you will feel the transformer having some noise which comes out. Okay, the third point is they have a lower efficiency. We said when something which is having lower efficiency, meaning there are some losses of energy, of voltages. Remember, you have the 12 voltage. Some voltages will be lost. Where? In the heating of the transformer, in running of the fans. That time when the fan is making noise, it produces heat itself. And that heat is loss of current. Heating of an inverter is loss of current. The current, when an inverter is in operation, it will end up heating on its home and on its housing, meaning the transformer or the gadget or the components inside, let's say the capacitors, the resistors, they will heat up. Even though some transistors are put on the heat sink, but you'll find out that the heat sink is not capable of carrying the heat. The heat sink, we shall look at those things when we reach at the electronics. Heat sink inside the circuit diagram, or the circuit which is inside the inverter. The transistor will emit more heat, whereby the heat sink is not capable to carry all the heat, and the transformer also in the interval of changing, of transforming or stepping up the voltages from 12 volts to 110 or 220 volts, it will end up heating up because of high current which is getting to be transformed high. Okay, and this I don't recommend my fellow technicians, the customers, the engineers, the beginners. Always go for, I prefer you go for pure sine wave inverters. It will make good for you in your work, in your solar installations, and your customer, the gadgets, will remain not affected. As we have seen that these ones, they did damage the sensitive appliances, and the customer will call you that you have undersized the system, yet it is the inverter which is bringing the problems. Okay, now the next video, don't forget, the next video we shall see, before you buy an inverter, what are the specifications you need to know before you buy an inverter. We are going to cover up the specifications which a technician or a customer need to know before anything happens, before you go and start sizing the car, or before you go to the market. What are you looking for? Leave alone looking for only an inverter, but there is something you're looking for. Next video, let's see the specifications. After specifications, then we shall go on and do the math of how to calculate an inverter. How do you know that this is the inverter I want? How do you know the wattage of an inverter? Because the inverters, they are sold according to the wattages it carries. Thank you for watching. See you in the next video. Don't forget to subscribe and like, share for more information about solar installations, electrical installations, and electronics as we are moving on with technology. See you there.